Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6. We'll present about the amplitude shift keying. This is our group member. ASK is a form modulation that presents digital data or digital signal as variation in the amplitude of carrier wave. ASK is a signal transform method when the amplitude of carrier signal change depend on the message signal. Simplest and most common ASK is referred to a on-off keying, which is OOK. In OOK, carrier wave transmitted or not transmitted depend on the input of message signal, that is 0 or 1. ASK amplitude modulation, which is AM, is a relatively simple and inexpensive modulation method for sending data via radio. Carrier signal amplitude should be greater than the message signal amplitudes. This is because when the amplitude is less than the message signal, such a combination modulation process lead to over-modulation and under-modulation effects. In ASK, noise or error will be measured by using signal to noise ratio, which is SNR, and also the bit error rate, which is BER. In modulation process of ASK, we have data signal, carrier signal, and also ASK signal. We can see the data signal will multiply with carrier signal to produce a ASK signal. So, this is an example of message signal, an example for carrier signal, and also the example of ASK signal. The example of message signal equation, which is 1 over 2 plus 2 over pi multiply with cos omega t minus 1 over cos 3 omega t plus 1 over 5 cos 5 omega t, and so on. So, the example of carrier signal EC cos omega t, where omega c must be greater than omega m. So, after the modulation, we can get the ASK signal equation like this. The VC will multiply with the VM. So, we can produce the ASK signal equation. We have two process demodulation process, which is a synchronized ASK detector, synchronized ASK detector. For a synchronized ASK detector, we will use rectifier, LPF, and comparator to produce the data signal. So, next, for synchronized ASK detector, which is we have square law detector, low pass filter, comparator, and also the voltage limiter. So, these two processes is to change the ASK signal to go back the data signal input.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Hanif Vichim Amri. So let's continue to the simulation of the mallet of the amplitude shift keying. So first we clear all the buffer or whatever input before. Next, I'm doing the digital or binary input information. So we need to manually input whatever number or binary we want. Later on we show you. Next, we have we convert the input into the digital signal. Okay, for example, if the input is 1, so it will become ones, include in ones, and 0 will be 0, and it will be sort of number like 0, 1, 2, 3 or whatever. Sorry, 0, 1, 1, 1, 0 or whatever. So next, we are drawing or plotting our first graph, which is the digital input signal graph. We can here digital input signal graph. And next, we are doing the ASK modulation, which is we have, if you wonder why I use two amplitude here. Okay, for example, in this digital graph, we actually need to multiply one by one graph. For example, for the first time, we need to multiply one by one. So first time, second, third, and fourth, because this is not like a normal graph. So we are using the 10 volt or 10 and frequency of 10 kilohertz. So next we plotting the second graph, which is the carrier signal graph, which is equal to amplitude multiplied cos 2 pi frequency over time. So we have the carrier signal, and then this is the coding for the ASK modulation, can see here if the binary is 1, so if multiply 1 by 1, and we have the third graph, which means the ASK modulated signal. I will show you later on. Okay. Okay, next we continue to the ASK demodulation. Okay, for demodulation we are using the same carrier frequency or carrier signal, and we do the convolution. After that, we're doing the integration, and we are converting back to the digital. I mean, you're sorting back the value if equal to 1, if it's 1, if it's 0, and 0. And here, we represent back the demodulated information into the digital signal. You can see here, this is the same process as before. This is 1, we equal 1, this is 0, it will be 0. And here is the fourth graph, or the last graph. This is ASK demodulated signal. Okay. Okay, so let's run the program. Okay, let's enter the input with 0, 1, 0, 0, 1, 1, 1, 0, 1, 0. Let's see the outcome. Okay, you can see here. This is our graph. This is what the, sorry, we need to wait. Okay, this is the input we insert, which is 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 0. So this is the carrier signal, which is the 10 volt, and the frequency is 10 kilohertz. So you can see here, this is the ASK modulated signal, which is here is multiply this one with this one, so we get this one. And when the digital input signal is 0, so that the ASK will be 0, and here you 1, 0, and 0 again. And after that, we convert back we demodulate the signal from the ASK demodulated signal to the ASK demodulated signal, so we get back same as digital input. Here we got the ASK demodulated signal. Okay, that's all for me.
Moving on to the analysis and discussion of ASK. From the binary input of 100, 111, 010, we get these signal graphs. After accepting the input, the program will run and produce the message signal, the carrier signal, the ASK modulation signal, and the ASK demodulation signal. Signal produced is the same as our previous researches and reference. The ASK shown was performed by using a multiplier. When received bit 0, the signal amplitude becomes 0. When received bit 1, it will give a maximum amplitude of the carrier signal. This shows that ASK is easily implemented and generated. Although noise interference will affect the ASK signal, the high bandwidth it produces covers for the disadvantages. Synchronous ASK has the best reduction of input additive noise. This type of signal can be used as a balance modulator for modulation and product detector for demodulation. In conclusion, based on this assignment, we can get more information of ASK signal. ASK is a form of modulation that displays digital data signal of the carrier wave amplitude in constant flux and depending on data messages. ASK acts as a transform method to change the amplitude of carrying signal. The amplitude of the carrier signal must be higher than the message signal for ASK to work. The advantages of ASK that were mentioned were the ease of implementation in any system, the simple receiver design, and the transmission through optical fiber or high bandwidth frequency. With that, thank you.